Hello friends, welcome back to Relief Tutorials again. In the previous lectures, we have discussed about elements, compounds, mixtures. There were two types of mixtures, homogeneous mixture and heterogeneous mixture. Homogeneous mixture means where the substances mixes together evenly. The density of substance is equal everywhere. Heterogeneous mixture means the substances do not mixes with each other thoroughly, evenly. The density of components of mixture is different. Based on that, we have seen one topic. There are two types of mixtures actually, homogeneous and heterogeneous, okay, but on the basis of how the solute substance dissolved in solvent, we have three different types of mixtures. The first one was already we have discussed, that is true solution. True solution is normally said as only solution. In solution, solute particles completely dissolved in solvent. Solute particles are converted into its molecular form, and the size of that molecular form is 10 raised to minus 9 meter, or we can say it is 1 nanometer. All these things we have discussed. Just we are doing the quick recap. These particles once get dissolved in solvent, they can't be seen. With naked eyes, they cannot be seen. They are not going to scatter the beam of light passing through that. Do not scatter beam of light, so the path of light will not be visible. Solutions are quite stable. See, most of the students forget the meaning of stable. That stable means composition of mixture remains same. Means if you keep the solution undisturbed, solute particles are not going to get settled down at the bottom. For example, this is the solution of NaCl. The best example of solution is what? Solution of common salt in water. That if you have dissolved NaCl in the water, the molecules of NaCl distributed equally everywhere. So when you keep this solution undisturbed, the particles of solute are not going to settle down at the bottom due to gravity. So no matter whether the solution is in motion or steady, the composition of mixture remains same. This type of solution is called as true solution. We have seen many examples. Examples of solution, we have seen the solution of common salt in water, solution of sugar in water, solution of aerated drinks in which carbon dioxide is dissolved throughout the liquid, tincture of iodine, in which tincture of iodine means iodine, the solid substance dissolved in alcohol, which is used in the dressing purpose. We have two more types of mixtures based on this how solute dissolved in that, and they are suspension And one more type is colloidal solution. Here only just let us see about the suspension first of all. Let us compare suspension with the true solution. True solution. Here the solute particles are distributed equally everywhere. The density of NaCl remains same everywhere. If you take the sample from here, sample from here, sample from the bottom, you will find equal amount of NaCl and equal amount of water everywhere. That is why true solution is nothing but one type of homogeneous mixture. Two substances mixes evenly everywhere. Now what is suspension? First of all, in suspension is one type of heterogeneous mixture. Colloidal solution we are going to understand later on. Right now just I am writing about the suspension. Suspension is a heterogeneous mixture. True solution is actually homogeneous mixture. Suspension is heterogeneous mixture in which solute do not dissolve in solvent. The first difference between these two is in true solution solute particles dissolved in solvent, and here the particles do not dissolve in solvent. Okay, consider here is one of the example. Consider this is water. Now let us add chalk powder. We know that chalk powder is not going to dissolve in water, so it remains undissolved, and you will see that chalk powder is roaming here and there. The density of chalk powder will not be same everywhere. Most of the particles are at the bottom side. So if you take the sample of the mixture from the top portion, middle portion, bottom portion, you will find chalk powder is different everywhere. Here the solute particles are converted into very small sized molecules, 10⁻⁻⁹ meter. Here the particles of chalk will not be dissolved. They are not going to dissolve in water. So these particles can be seen easily with the naked eyes. Okay, the particles of solute here, solute can be seen with naked eyes, and in the true solution solute particles cannot be seen with the naked eyes. Here the mixture is homogeneous, here the mixture is heterogeneous. Here the solute particles are converted into its molecules. So actually here we can say that solute particles are called as molecules. Solute particles are named as molecules, and here the solute particles are named as suspended particles. See, suspended actually means undissolved. So the name of the solute particle here is called as suspended particles. Okay, and the solvent which is used here, is named as suspension medium. You can say only medium also. Here the solute particles are named as molecules because the size of molecule is nearly equal to the size of molecules, 10 raised to minus 9 meter. They cannot be seen with the naked eye, but here the solute particles are named as suspended, means undissolved particles, so they can be easily seen with the naked eyes. Solvent is named as medium. Okay, in such type of suspension, this solution is now called as what? This mixture is now called as suspension. Okay, this mixture is called as solution or true solution. This mixture is called as suspension because here the particles are suspended, means undissolved. Okay, so now let us pass the light ray. So if you think, let us consider this is suspension solution. Here the particles are unevenly distributed, and if you pass the light ray from it, what could happen? Because the size of particles is quite big, it can disturb the path of light, means it can scatter the beam of light, means the beam of light will be scattered and the path of light is visible. Here we have understood that if you pass the beam of light, what would happen? The light cannot be disturbed because the size of these solute particles are quite small that they are not able to disturb the path of light. But here the path of light can be disturbed. So what we can write the next is the suspension scatter the beam of light, so path of light is visible. Now the solution, if you keep the solution as it is, undisturbed, steady on the table, the solute particles are not going to settle down. That is why composition of mixture remains same. So that is why the true solutions are stable. But what about here? Now if once you mix the chalk powder, you are stirring them, means the chalk powder is present everywhere in the solution in the uneven amount. The density will be different everywhere. But now if you keep the solution undisturbed for some time on the steady table, flat table, then what? Then after some time, what we will observe that the solute particles settle down at the bottom. Previously they were moving here and there in the uneven amount everywhere, but once you make it steady for some time, undisturbed for some time, the only water left here on the top part and all the heavy particles of solute settle down at the bottom. So now this is not called as suspension because now the two substances almost get separated from each other. We can see the boundary between the solute particles gathered here and the solvent is over that. So now there is no mixture exist here. There is no suspension exist here. So remember, when you place the suspension solution steady for some time, all the particles of solute settle down at the bottom, and this situation is called as suspension breaks. So here the suspension breaks, so now it is not able to scatter the light. Such type of solutions are called as unstable, because when the particles settle down at the bottom, no mixture exists because two substances are separated now. We can see the boundary between them. Such type of solution is unstable. So the huge difference between this stable and unstable. True solution is stable, suspension is unstable. True solution do not scatter the beam of light. suspensions can scatter the beam of light, but when the suspension breaks, there is no scattering of light. Remember, here the solute particles are known as molecules. Here the solute particles are named as suspended particles. Here the solvent is named as solvent only, but here the solvent is named as medium or suspension medium, whatever you say, otherwise simply medium. Here the particles cannot be seen with the naked eye. Here the particles can be seen with the naked eye. This is stable, this is unstable. Can we separate these two by filtration? In the true solution, particles are too small that they cannot be separated by filtration, but here the particles are quite big, or they are big enough that they can be separated by filtration. So the last point of difference between these two is what? Here the solute can be separated by filtration process. They can be separated by filtration. So that's why I have taken the use of this page here in place of board, that we can compare these two simultaneously. So we have the comparison between true solution and suspension solution. So what to remember in the suspension? Suspension is one type of heterogeneous mixture. The particles cannot be seen with the naked eyes. Solute particles do not dissolve in the solvent. Suspension scatter the beam of light, so the path of light is visible. But once the particles of solute get settled down at the bottom, suspension breaks. So now there will be no scattering of light. Many such examples you can take for suspension, that the mixture of chalk powder and water, mixture of sand and water. I think you have seen the smoke coming out of chimneys of the factories. Such many more examples you can find around you. Okay, so this is the comparison between true solution and suspension. And now let us see the colloidal solution. See, colloidal solution is the intermediate situation. Listen to me carefully. It's an intermediate situation of what? It's an intermediate situation of solution and suspension. We have seen that in solution the particles are completely dissolved, and in suspension the particles do not dissolve. In true solution the particles cannot be seen with the naked eye, and in suspension the particles can be seen with the naked eye. Okay, what is colloidal? Colloidal solution, first of all, it's the heterogeneous mixture. It is the heterogeneous mixture, but seems to be homogeneous. It is actually heterogeneous but seems to be homogeneous, appears to be homogeneous. The particles, see here in the solution we have seen that the particles are evenly distributed everywhere. Here the particles can be seen, in the suspension particles can be seen easily with the naked eye. They are not uniformly distributed. But here the size of particle in the true solution is very small, and here the size is too big that they can be seen, but here the size of particle is intermediate. The size of particle of solute is bigger than molecules, means bigger than the particles of solution, but smaller than the particles of suspension. Okay, so this is the intermediate situation in which the solute particles are neither too small nor too big. Yeah, with the naked eyes in the ordinary condition they cannot be seen, but if we focus the light on them they can be seen. Let me give you the best example to understand the size of these solute particles. Consider, you might have experienced this fact. Consider this is the house. Consider your room itself, your home itself. We know that the particles of dust are moving here and there. But in the normal condition, the particles of dust cannot be seen. But now consider, here is the hole on the roof. So the beam of light enters like this. Now the dust particles present here. You can imagine the dust particles here. Right now I am not drawing them because in the normal condition dust particles are not visible. Now once here is the hole, now the beam of light enters. Now what happens? You might have observed that the dust particles which are coming in the path of light can be seen, and the path of light becomes like this. And here we can see the particles. Have you experienced this thing? Many times. For example, your room, your classroom maybe, or your room at home is totally darkened. Each windows and doors are closed. Now let the beam of light come into your room through any one of the small opening, through any window or one of the door. So the light rays coming from that small opening, that light rays are scattered. It seems to be they are expanding like this. They are expanding, they are increasing their region. Okay, and the dust particles which are coming in the path, these particles are able to scatter the light because they are not too small and not too big. If they are quite big, then they should be visible easily. And if they are too small, then they do not scatter the light. But here the scattering of light can be seen. This effect is called as Tyndall effect. Which effect? Which effect is called as Tyndall effect? When the light rays are scattered by this type of small particles. Already we discussed that in the solution, the solute particles are called as molecules. In suspension, solute particles are called as suspended particles. Here, the solute particles, listen to me, it is very important. Solute particles are called as colloidal particles. If someone asks you about the size of the colloidal particles, then what? So you can say that the size of colloidal particles is bigger than molecules. Bigger than molecules but smaller than suspended particles. Okay, so here the solute particles are called as colloidal particles. Also it is called as dispersed phase. They are also called as dispersed phase. So here these dust particles are called as colloidal particles or dispersed phase. You can imagine this, the air in your room is a mixture of air plus dust particles. So air is behaving as solvent because it is present in the more amount, and dust is what? The solute. But because it is a colloidal solution, dust particles means the solute particles are called as colloidal particles or dispersed phase. Here the solvent is called as dispersion medium. Solvent is called as dispersion medium. Is that clear? So what to remember? Colloidal solution is the heterogeneous mixture, but it seems to be homogeneous. Solute particles are neither too small nor too big, so they are called as colloidal particles. Solvent is called as dispersion medium. So here in this example, it's an example of air plus dust. So air is solvent, dust is solute. These particles are able to scatter the light. Colloidal particles are able to scatter the beam of light. So the path is visible. So the path of light is visible. So this effect of scattering of light due to colloidal particles is called as Tyndall effect. This effect is called as Tyndall effect. You might have observed that when you go to see movie in the theaters, one of the projector is there at the last wall or at the back end. So from that projector, the beam of light is falling on the screen. So that beam of light, it seems to be scattered. Or you can see you also observe that the light coming from the projectors at your school, for the light is falling on the whiteboard, also seems to be scattered. And also the dust particles coming in the path can be visible. So this effect of scattering of light, listen to me again, the effect by which the scattering of light is observed by the colloidal particle, this effect is called as Tyndall effect. Many such examples you can think about this. For example, the fog. We have seen the fog in the winter season, normally in the morning time. In the fog, what happens? It's a mixture of air plus tiny water droplets. So air behaves as dispersion medium, means solvent, and tiny water droplets behaves as colloidal particles or the dispersed phase. These water droplets are not too small and not too big. So these water droplets are able to scatter the beam of light. Okay. Now if you think that the air which is present here is undisturbed, steady for some time. So is it so that all the dust particles are settled down at the bottom? It is not going to happen. So this solution is stable. Already we have seen that true solutions are stable. Suspensions are unstable. In true solutions, solute particles can be separated by filtration, cannot be separated by filtration process. In suspension, the suspended particles are big enough so that they can be separated by filtration. But here in the colloidal again, the size of particle not too big so that they cannot be separated. Can't be separated by filtration process. They are stable, they cannot be separated by filtration process. We have a quite interesting technique. We will see that technique to separate the colloidal solution, separate the colloidal particles from the solution. That process is called as centrifugation process. The process of separating colloidal particles from the solution is called as centrifugation process. How this process works and what is the technique, that we will see in the next part of the chapter. But for today, it is three types of solution we have seen: solution, suspension and colloidal. You can have a difference. Let me speak it fast. True solutions are homogeneous, suspensions are heterogeneous, and colloidal are again heterogeneous but seems to be homogeneous. In true solution, the particles of solute cannot be seen with the naked eye because they are quite small. In suspension, the particles can be seen with the naked eye because they are quite big. Here the solute particles are known as molecules. In suspension, solute particles are known as suspended particles, and in the colloidal they are known as colloidal particles. In true solution, the beam of light do not scatter. In suspension, the beam of light scattered till the solution exists, but once the molecules are settled down at the bottom, suspension breaks and no scattering possible next. This is in colloidal solution, the particles are of intermediate size, so they are able to scatter the beam of light continuously. The beam of light can be scattered by the colloidal particles, and this effect is called as Spindle Effect. Fog, air plus dust, and such many examples are there of colloidal solution. Colloidal solutions are stable and cannot be separated by filtration process. The particular technique to separate the colloidal particles from the solution is centrifugation. We have different types of colloidal solutions are there based on the mixtures. Let us take some examples of colloidal solution. See, first types and examples we are learning here. First type is aerosol. In aerosol, we are adding two things here: dispersed phase and dispersion medium. Dispersed phase means actually solute, and dispersion medium means solvent. So, if any liquid particle mix with the gas, just like we have taken the example of fog, in which air is solvent, means air is gas is dispersed medium, and water droplets means liquid state is in solute state. So that is nothing but the example of, so this type of colloidal mixture in which liquid is dissolved in gas, that is called as aerosol. Aerosol is also the mixture like this. When solid mixes with gas, then also it is called as aerosol. Smoke. In smoke, the solid particles, automobile exhaust, the smoke coming out of vehicles contains solid particles mixed with the gas. So that is nothing but the example of aerosol. Foam. Foam. It's a very common word in which the gas is trapped in liquid state. So example for that is shaving cream. Emulsion. One type of liquid is mixed with another type of liquid. like milk, in which the fat particles mixes with milk particles. So both are in liquid state. So this type of example is the example of emulsion. Milk, some face creams, then we have the example of sol. The type of colloidal is sol, in which the solid mixes with liquid. When solid mixes with liquid, it is the example of sol. The examples are milk of magnesia and mud, in which the clay particles mixes with liquid, water. Example of sol that was. Then gel, when liquid mixes with solid, like jelly we have seen, cheese, butter, then we have solid sol, in which solid mixes with solid, just like the gemstones, you can say, the stones which we wear in the rings, milky glass. This way. So these are the types of colloidal solution, and these are some examples. Not everything you have to remember, but try to remember as much as possible. Okay, so here is the end of the three types of solutions: true solution, suspension solution, and colloidal solution. You can make a notes by observing this video carefully. Try to remember each and everything. In the next session, we are going to see the separation method of mixtures. Till then, best of luck.